Before we move on to geometric sequences, let's just have a quick revision on arithmetic sequences. So this is an example of an arithmetic sequence. Each time you're adding 2, so 3 you add 2, you add 2, you add 2, you add 2, and so on. So each time 2 is your common difference. Each time you're adding 2. Let's just look at this example here. Let's just look at this example with the number 9 here. You start with your initial value, which is 3, and then you add your common difference 3 times. So you start with your A here, and then you add it 3 times. So 1, 2, 3. So it's really you getting your common difference and then multiplying by 3 because there are 3 lots here, and so on. You should have already seen this in high school. So by right I should have brackets here, but let's just keep it nice and clean. So let's just look at an example where we add up the first 5 terms. So let's just try and add up the first 5 terms. So that's from n equals 0 to n equals 4. So from high school, to add up the first 5 terms here in this example, we would get the first term, which is 3, add it to the last term, 11, and then quickly divide it by 2 to get the average, and then times the number of terms, 1, 2, 3, 4, 5. So this here would then give us the sum of the first 5 terms. In this video, we're going to try and find out how they came up with this formula. So this is just revision, so you should already know this. So let's just look at this sequence as an example. So the first, so looking at this, the first term is the first term A equals 3. The second one, remember, you just added one difference here, one common difference, which is just 1D. The second term is you starting at your first, and then you're adding twice the common difference, 1, 2. So this would represent your first, second, third, and then it's blah blah blah. Let's just look at the last term. The last term would be this, and then the second to last term would be you getting the last term, which is the 15 here. Take away your common difference. Remember, normally it's plus 2 each time. Normally it's plus 2 each time. So the second to last term is you getting the very last term and then take away the common difference. So this second to last term is you getting the very last term, which is L here. Take away the common difference. Take away what common difference, and then the second to last term, which is this one here, is you getting the last term. Hang on. Each time you're adding 2, so you add 2 here, and then you're adding another 2 here. So you would get your last term, and then you take away 2 lots of the common difference. So it's this and this. So that would, and so on. So you can write this. You can write the whole sum as this thing here. So the trick is to rewrite the exact same thing, but in reverse order. So you put you put your last term first. So this, well, you rewrite it in reverse order here. And so basically this is still Sn. So Sn is this, and this Sn is still also this, but just in reverse order. So now you add up. If you add up, hang on, let me, bear with me. Now if you add up the two terms, the two series, hang on, bear with me. Now if you get this, add this, that will then give you 2 Sn. So looking at the first one, this add this will give you A plus L, and then this add this, well, remember you got add D and then you take away D. So this, if you get this add this, it will then give you this. And then look at the third term, get this plus this, it will then give you this. Look at this one here, get this plus this, and so on. It's all going to be A plus L, A plus L, A plus L. So now there are n lots. So that's n there. And then so it's really what we did earlier. We would get our first term, add our last term, quickly divide it by 2, and then times the number of terms. So that's how we got that formula. Okay, so in the next video we're going to move on to geometric sequences.